let's start from where we left off. Our agreement was that Vuyo will share with us his answer for number 2, the one that we were busy with yesterday. And then from there, Lebo and Erica. Oh, we said Lebo and Erica will rework the same exercise and then share with us what they found as their answers. And then we agreed that we will take number 3 home as a homework. So let me just say number 1, number 2, and number 3. So let's start with Vuyo. Vuyo.
Yes, sir.
How are you, brother?
I'm good, and you, sir?
I'm okay.
Thank you.
What did you get as an answer to number 2, brother? The one that we were dealing with yesterday.
Sorry to interrupt, sir. Okay, thank you, sir.
Thank you, my brother. Please go ahead.
I did rework that exercise, and I got y is equals to 255 over 16x minus 73.
Are you sure, Vuyo?
I'm 100% sure, sir.
Okay. I'll buy you an expensive chappies. Thank you. Lebu and Erica. Who is going first? Lebu, Erica. After reworking number 2, what did you get as an answer?
Hello, I've got y equals 255 over 16x. Take away 182.
Take away 182. If you don't take away the 182, what is that number, Erica?
255 over 16x.
Minus
182.
Minus 182.
Yes.
Okay, Erica, you say y, you found y is equals to 255 over 16x minus 82.
182.
Minus 182. Erica.
Yes, can I change my answer? I was on the wrong paper. It is, it's minus 73.
Minus 73.
Yeah.
Why? Why did you change from minus 182 to minus 73?
I made a calculation error. Instead of having a minus 255 over 2, I had a positive one, and that's where I made the mistake.
Okay.
Yes.
Now, may we please double check. Okay. May we please double check what you got as an answer for number 3? I know here we have got Erica, we have got Abdul, we have got Kogetso. Oh, Lebo will rejoin. We have got Mahlatsi, we have got Sibusiso, we have got Tando, we have got Theo, we have got Vuyo. I'm not mentioning anyone's name here. Anyone can go. Okay. Hello.
Hello.
Yes, Lebo.
Oh, Hello, sir.
Hello. Hello. Yeah, I can hear you.
How are you, sir?
I'm good, and you?
I'm fine.
Yes, thank you. My sister,
Yes, sir.
remember our agreement.
Yes, sir.
Can you be able to keep our promise?
Yes, sir.
Did you keep it?
I did.
Hey, I'm happy to hear that.
Yes, sir.
What did you get as an answer for number 2?
I got y is equals to 255 over 16x minus 73.
I'm happy.
Oh,
I'm happy.
oh,
And thank you for keeping our promise.
yes, sir.
Thank you very much. Now, I'm not mentioning any name, but I know that here we have got Erica, Abdul. Oh, Abdul. Abdul. Is Abdul here?
Yes, he is.
My brother,
Yes, sir.
I think I'm speaking under correction. It looks like you were not here yesterday, né? With us.
Yes, I was not with you guys yesterday, sir.
Yes, okay. And I am not sure whether you did, whether some of the family members or the family members did share with you number 3, which we agreed that we'll take it as a homework and then we'll start by verifying an answer today. Did you get that information?
I'm checking it now, sir. I didn't get that information. However, I'm busy with it right now as we speak.
These members are disappointing me now. Abdul, I didn't expect that. I thought they would.
Load shedding, say, no, I'm not gonna blame them because I was being load shed, say, so there was no way. I don't think there was a way that they could have probably communicated, if ever. I'm not sure, but I would say it would be harsh on them.
Mm-hmm. But no, what I'm just saying, is to say, let's try to share information amongst ourselves.
Noted, sir.
Yes. So that we can be able to move at the very same speed. Okay. Now, if that is the case, where should I start? Hey, Tando, were you here yesterday? I don't think so.
No,
Mister.
sir, I was around.
You were not here.
Yeah, but I'll try to do it now.
Okay, I will give Abdul and Tando an opportunity to work it out, then we'll talk to them later. Now, let me start with, okay. I'm going to start with Kogetsu. Kogetsu,
Yes, sir.
how are you, my brother?
I'm doing just fine, sir. And you?
Thank you very much. What did you get as an answer for number 3, which was a homework for us?
I know I wasn't part of the group at the last minute, but I tried to do it now. I got Y.
Yes.
I got
Why?
Y.
No, hang on.
equals
Whoa, hang on. You said you were not here yesterday with us.
Yes, at the last minute, sir.
Oh, okay. All right. No, I got that one now. Okay,
Yes.
brother. What did you get?
It's Y equals to minus 5x
Yes.
plus 7. My seed 7, yes, plus 7.
Y equals to minus 5x
Minus 5. Yes.
minus 5x plus 7.
Yes.
Okay. Thank you, my brother. Now let me go to Erica. Erica,
Yes. I've got
what?
y equals negative 5x plus 7.
Thank you, Erica. I'm now going to Lebo. Lebo,
Hello, sir.
how are you?
I'm good, sir. How are you?
Yes. What did you get as an answer for number 3?
I got negative 5x plus 7.
Are you sure?
I'm 100. So it's a no.
Mhm.
Hey.
Now,
I was thinking last minute.
okay. Now let me go to Matatse.
I got minus 5x plus 7.
Are you sure?
Definitely.
But how you people? Hey, how can you just be copying things that I'm not looking for from each other? I suppose it's so.
So we're not copying.
You're not copying.
No,
Are you not sitting together?
no, sir.
But now all of you are just telling me the very same thing.
Meaning it's the correct answer, sir.
Yo.
Ow.
Or
Ay,
maybe
yeah.
you're having the different one.
Yes, I'm having a different one here.
Or
Okay,
maybe we
sir.
can go through
Sorry?
I'm saying maybe we can go our working.
Maybe what level?
We can go through our workings, explaining our workings.
Yeah, let me go through this list. Sibusiso,
Yes, sir.
how are you, brother?
I'm finding you, sir.
Good. What did you get as an answer, my brother?
I got y is equals to negative 5x plus 7.
Negative?
5x
Yeah.
plus 7.
Negative 85x.
Negative 5x. 5x, not 5x.
Yeah. You people, I don't know. Now let me go to, okay, thank you, Spiso. Let me go to Theo. Maybe Theo will be able to give me what I'm actually looking for. Theo?
Yes, sir.
Yes.
My answer is y is the equivalent of negative 5x plus 7.
Okay. Thank you.
The equivalent of.
Yes. Yes. Yeah, it's different from them.
It's very different.
Yes. Yes.
It's tomato.
Yes. Vuyo,
Yes, sir.
my brother, what did you get?
I got y equals negative 5x plus 7. We are sitting together. We got the same thing.
Yeah, I see that. Now, let me talk to Abdul and Tando. Maybe they can be able to help me out because all of you are not helping me out. You are just making my life difficult. Abdul?
I'm also gonna make your life difficult, sir.
Yeah.
So I
Yes.
agree with your colleague.
You agree with them?
Yes, sir.
Yeah. Tando, I trust you. Tando,
Hello, sir. I still need 2 minutes. I'm
still need 2
halfway.
minutes?
Yeah.
Okay.
You can continue. I'll give you the answer.
No, this is not how we operate. We are waiting for you. We are giving you that 2 minutes.
Nah, so
We are waiting for your answer. While we are giving you that 2 minutes, I need us to look at something here, and then Tando will join us here. Do you see this exercise said 2.2e.6?
Yes, sir.
Yes. We are not going to do everything here because I need us to go to the next section that we talked about, that is dealing with the derivatives of trigonometric functions. May we attempt to do number 1? And then, is Lerato here today? Or is still
No.
busy? Or no, I understand. Who should I ask? Matlazi, how many minutes
Yes,
do we
sir.
need? How many minutes do we need to work out number 1?
3 minutes.
So we need to sketch the graph, sir. Oh, what's happening?
Whoa, let me see. Hang on first. In this case, all right, okay. Hang on. The only thing that I'm requesting you to do, ne?
Yes, sir.
Okay, no, let me wait. Wait. Okay. In this case,
I'm done, sir.
Are you done, Tando? Yes, my sister. What did you get?
Same as they are saying. Y is equal to negative 5x plus 7.
Are you sure?
Yes.
Number
It shows
1,
that
sir.
all of, sorry?
It's number 1. 2.2
Whoa, wait.
E.
Level, hang on. Tando was talking about number 2 in 2.2e.7. I mean, no. Our number 3 is what she was talking about. But now, it looks like all of you are sitting on top of this bridge, the one that I'm underneath, just sitting underneath. And somehow you are just hearing me, or you are just copying from me when I was working out this exercise, because you got the very same thing. Or maybe one of you was just standing on top of the bridge watching me working out this exercise, and then called all of you to give you the answer. Thank you. The answer that we were looking for number 3 is y equals to minus 5x plus 7. Okay, let me request you in this way. Let's step off this section. Forget about this exercise that I needed us to focus on. Let's step off this section. I think from my side, I think I'm happy, and then I've covered what I needed to cover with you. Are you okay? Is that okay with you?
Yes.
Listen.
Are we agreeing?
No.
No. Okay.
Yeah, sir. You are saying we must pass this session and going through another session. So I don't know, what about normal lines? Because we only done tangent.
Normal lines.
Lines. Yes.
Are they in this module level?
Yes, sir.
Yes, sir.
Yes, sir.
Am I missing something here?
You are missing normal lines.
I'm missing normal lines.
Yes.
Level. Thank you for reminding me, but let me. Where is this?
So something is not normal here.
Yeah, something is not normal.
What's not normal?
Something is not. Where are these normal? I'm looking for these normal lines. No. Have you got your study guide with you?
Yes, sir.
Page number.
Okay, sir. Let me check.
Normal lines.
Normal.
Huh?
Sir, I'm checking for you.
Yeah.
It's page 80, sir.
The question.
8.
Yes.
Did you give us a question to do right now, sir?
No. We are waiting. Don't do it.
Oh.
Please
We are
don't do
done.
it.
Yeah, page 8, sir. From page 8.
80.
Yeah, from page 8.
80. Okay, wait. Oh, my sister. Now I understand why. Oh, it's because tangents have been paired with normal lines here.
Yes, sir.
Okay. Now I see what you mean. Let me make this request. Okay. Here is my request, Lebona. Yeah, I
Yes,
see
sir.
why. I see why. This is under implicit differentiation, né?
No.
Oh, 4 point implicit differentiation tangent. Oh, this
After
section.
tangent.
No. Okay, level. Thanks. They follow each other. Now, here is my request, my sister. Né?
Yes, sir.
Can we? Is my plea to you.
Can
we? May we please deal with this after dealing with the next section of this one of trigonometric functions?
No problem, sir.
Yes, and I understand why, and then you will see why it is not. I didn't even include it here because ideally, when it comes to this section, we are just going to focus with what is in your study guide. Okay, so on this section, I'm not going to spend much time. This one of implicit differentiation and yes, thank you for shows that you do go through your study guide. Implicit differentiation and this one on tangents and normal lines. What I'm going to do, I'm just going to go through these sections. I'm going to cover them the way they are in the study guide. So please familiarize yourself with the way this section has been covered in the study guide. Okay.
Implicity.
Yes, that's my request. Meaning, Go through this implicit differentiation as well as that section that deals with tangents and normal lines.
Okay, sir.
Make sure that you understand it. I'm just going to pick up a few questions from each section. Then I'll be done with these two sections. Okay.
Yes, I need to give advice to our family.
Yes.
Family, I recognize something. Ne? Study guide is very important. You have to do those questions, all of them. I saw some question paper, the one that they were writing on January or June, or is it January or June? Yeah, first semester when there were examples that were in study guide. I don't know, but like they will pick those questions on study guide and they will be there on our exam in simple words. So please
Thanks,
do
ma'am. Noted.
that, yeah, on study guide, all of them.
Okay.
Even on our assignment, they took them here on our study guide.
Oh,
Mm-hmm.
oh. Yo.
Sir.
Yeah, bo.
Lebo,
Okay,
may I ask you something?
Uh-huh.
Is this for this module or generally most of the modules we do?
I think this module, cause I didn't saw it for module 1503.
I was about to ask you that question.
Yeah, for 1503, they want us to fail that module
It's hectic there.
straight away.
It's hectic there. I know.
It's hectic.
And I don't know if it's me, but I also feel like when we have those discussions with Dr. Ali, you leave feeling even more confused. So maybe it's just me.
Yeah, this module, I'm telling you.
Charlie's killing us, man.
No, actually, they don't want us to qualify for exam because they know exam is easy.
Dr. Glenn, why aren't you the one giving those discussions? Hey, Dr. Ali, man, no. No, man. Hey, that guy, man, no. And the thing is, he's interesting because you can tell he's smart and you can tell he knows what he's doing. But, hey, yeah, man, hey.
What's wrong? What's wrong?
Hey, so all I'm going to say is those discussions, I generally try not to attend them because I always leave feeling, if not just this confused, more confused than I was when I walked in. Ish. And I know some of our team members here attend those discussions because I saw some of them in the morning, and I was just sitting there on some. Hey, I think I need to get a cup of coffee, man. Hey. Anyway, let's continue.
Here is my advice to you.
Yes, sir.
Okay. On this section, that's why. Okay, these two sections that we are talking about, that level just brought to my attention. I treat them exactly from the study guide.
Okay.
Yes. That's why I'm saying, please, do me a favor.
Yes, sir.
Go through this section 4.5.6 of implicit differentiation, as well as this one of section 4.5.7, tangents and normal lines, here in the study guide. Just go through those exercises. If you don't follow, don't panic, then we'll deal with them together. But here is my request to you. Let's go and talk about derivatives of trigonometric functions. And then immediately after that, please remind me so that we come to these 2 sections. Okay,
Yes, sir.
thank you. Now where,
Eh,
oh,
Before you continue,
yes, who's talking?
Mahlatsi,
Yes, Masas.
on our number 3 that we did yesterday,
Hmm.
were you expecting us to, when solving for f at prime, were you expecting us to solve it as a product? Like solving the f at prime using the product rule?
Oh, okay.
Or you were
Before,
just supposed to simplify the equation and solve?
before I come in, did you get the very same answer? Oh yeah, no, your name is here. You said you got y equals to minus 5x plus 7. Okay?
Yes.
Now, before I say anything, before I respond to your question, please share with us how you approach this.
Sir, I
Because
just
hang on. The reason I picked up this one is because it's different from number 1 and number 2. Did you notice that?
yes, sir.
That was the reason I picked that. Okay. The stage is yours. Now you can dance.
Sir, firstly, I simplified my equation. And then, what can I say? What's this rule? At the end, I got, was it x to the power 4 minus 2x cubed minus 6x squared plus 9x? And then I was busy asking myself, was I supposed to use the product rule or must I just simplify this equation and then differentiate?
Okay, without wasting time, in this case, this is straightforward. When you are facing this kind of a situation, BODMAS. Remember BODMAS?
Yes, sir.
Are you sure?
Yes, sir.
Get rid of the brackets. Get rid of the brackets first, then you will be able to handle this. All right. Is that the way you did it?
Yes, sir.
That's the way to go.
Okay, sir.
Thank you.
Thank you.
Now I need us to, okay, let me put the study guide here. Then, where are we going? Okay. Let's go and visit this village. Okay. Let's talk about derivatives of trigonometric functions. All right, without wasting any time.
Finally.
Without wasting time, we all still remember this formula, the one that I've highlighted. Still remember it?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you.
Yes.
I'm happy that you are still remembering it. Remember, your exam is in few days' time.
When?
So,
It's when?
in few days' time. Don't worry about the date. I'm happy that you can remember this equation. Remember, we started with this kind of a thing.
Yes, you nearly give me heart attack.
I
Heart
thought
attack.
it's 2 days time.
No.
Nah, No.
No.
Right.
No.
No. Okay. Before I continue, all right, I heard you talking about the discussions that you are having, even the way you see the exam. But believe me, here is my advice to you. Please stay focused on what you know. Everything that we have covered, please make sure that each and every question related to the sections or chapters that we have covered, please collect maximum marks. I know that we can present the very same information but differently. But stick to your guns, stick to what you know. As I said, the intention of the examiner is not to trick you. The examiner is just interested in understanding how far you have gone in mastering the syllabus. And that's it. Please, I'm begging you, please get out all the negativities. Level of this being difficult, that, and no. Tell yourself that I am Lebo. I'm going to write this module and I'm going to pass. Okay.
Yes, sir.
That's my advice. That's my advice to you. Stay focused. Don't allow any other things to distract you. Please keep focus. If you can keep focus, you and I will reach our destination. Okay.
Yes, sir.
Now, let's start here. No, I don't want to bother you with this many backgrounds related to these other things. But let's get straight to the point. We all did metric in high school, né?
Hopefully. No
one skipped, let's say, metric and okay, it's grade 11 and in fact from grade 10. From grade 10, 11, and 12. That's where we started to talk about these trigonometric functions. Do we agree? Or am I not telling the truth?
You don't know, sir.
And I think that the deriving of these trigonometric functions started in matrix. So yeah, hey, hopefully, like you said, hopefully we have that metric.
Big hopefully, Mr. Abdul. Big one.
Sure. People, you are worrying me now.
So don't be worried. Continue, please.
Stick to your guns, say. Stick to your guns. Don't panic, say. Stick to your guns. Stick to the guns. You just told us now, say. So stick to the guns, say. Stick to the
You are the one that has doubt now. How?
Okay. All right. Please. I'm not going to be beating around the bush when it gets to this.
Yes, please.
We go straight to what we need to learn. Okay. What we need to know is that the derivative of the sine of x is cos of x. Okay? I'm sorry about that.
Bless you.
Thank you. Do you see this? Do you see this equation 2.4.5?
Okay. Can you
Yes, sir.
Do you see my screen?
Yes, but
Yes.
I hardly see, sir.
Do you see my screen now, Lebo?
Yes, sir.
Are you sure? I've expanded my screen.
Yes, sir.
Okay. What you need to know is that the derivative of the sine of x is equals to cos x. Okay.
Yes, sir.
Whenever we are required to find the derivative of sine x, we know that the derivative of sine x is equals to cos x. And the derivative of cos x is equals to negative sine x. This thing is simple and straightforward. Don't panic. Keep focus. The derivative of sine x is equals to cos x. The derivative of cos x is equals to negative sine x. That's it. Now we move. Here, they say the derivatives of the sine and the cosine functions. Here they say the derivative of sine x is equals to cos x, and the derivative of cos x is equals to negative sine x. See what is in here, what is in red here on this page. That is what I'm interested in sharing with you. The derivative of sine x. Level, even if I can break into your room tonight, when I say to you, when I ask you this question tonight, there is going to be a break into your house tonight. I'm going to ask you this. What is the derivative of sine x? If you can say to me it's cos x, then I will leave. But if you can fail to tell me that the derivative of sine x is cos x, I'm just going to remain in front, at the front door.
Basically, no pressure. No pressure.
Then the derivative of cos of x is equals to negative sine x. Thanks, Theo. This is how they are proving it, but that is not what I'm interested in. I'm interested in you knowing that the derivative of sine x is equals to cos x. The derivative of cos x is equals to negative sine x. Now, yeah. Remember at the beginning of the year, I asked you to know the sine curve and the cos curve by heart.
Yes.
Remember? Someone is saying,
Yes, sir.
Yes, sir.
Okay. Now, this is what, you know, if you know this, you know that cos curve is that at 0 is starting at 1, coming down at 90. At 180 degrees is negative 1, coming and resting at 0, and then going to the top at 1. That is the cos curve. The sine curve, we know that at 0, it is 0. At 90 is 1. At 180 degrees is 0. At 270 is negative 1. At 360 degrees is 0. Believe me, if you know these two curves, you will go places, you won't struggle. All those other trig functions are revolving around these two functions. Do you agree with me on that one? Or do we disagree? But I'm happy. You know what makes me happy? Is that I asked you long time back at the beginning to know this by heart.
So may I ask you something?
Yes, my brother.
Is it then safe to assume that basically the cosine curve is the equivalent of the sine curve, but it's been moved 90 degrees to the right?
No. No.
Okay. Okay.
But the gradients are opposite.
I see. Because I mean, I'm just looking at the sketch basically where, I mean, literally, if you were to take the cosine curve and move it 90 degrees left, it would literally sit on top of the sine curve.
Yeah, most definitely.
That's all I wanted to know. Thank you. Thank you. Thank you.
what is it that there is this thing that I need to say?
Please, please, please.
What do I need to say? What there is this thing that I need to say. Okay. If you know this, you know, if you know these curves over this interval, you can be able to evaluate any trig function at any angle. Please remind me, Lebo,
Yes, sir.
let's say I'm looking for the weight, looking for that weight. Let's say okay, give me a few seconds. Okay, this is what I need to say to you, Lebo. What I need to say is that there is a weight. There is this angle. This angle can be in the first quadrant. Ne?
Okay, sir.
Being in the first quadrant, but you will find that when you move around the point, it will be the very same angle in the second, third, even fourth. Remember, we are revolving all these angles. Do you see this zero here? You see this zero?
Yes, sir.
Remember on the, okay, we are now only focusing on the right-hand side. Remember that we have got, on the left-hand side, we have got negative pi over 2, negative pi, and negative 2 pi on the left-hand side. Eh?
Yes, sir.
And then these two functions are taking the very same shape on the left-hand side. Are you with me?
Yes, sir.
Mm-hmm. There is the weight. Any one of you can come in. We can, meaning, let's say this angle in the first quadrant is 45 degrees. But then this angle, it will be a multiple of 45 degrees in any other triangle, any angle, no matter how big it is. There is that weight that we use. Theo, Spusiso, Matas, do you understand what I'm referring to? There is a word for that angle.
Special angles.
Is it special angles?
No.
So are you talking about the reference angle? I don't know.
No.
I didn't say. I think we are lost. So.
I know. We are clearly lost. Please help.
Yeah, I think we are lost.
Aye, please help. Mr. Abdul, do you have a comment?
Well, I was also gonna say what Spusiso is saying, special angles, because
Okay.
when he mentioned 45, your special angles would be 0, 45, 0, 30, 45,
and 60.
90,
and 60.
or 60 and 90. Yes.
Yeah. Aye, but I think
so if it's not anything within that, now I think so is confused.
Aye, no, it's fine. In that case, let's all give it a shot. Miss Erica, do you want to try the lottery?
Can I?
Erica?
Yes.
Do you remember, let's say this angle is 45 degrees in the let's say in the first quadrant, né?
Oh,
and then this angle. Oh, Abdul, you get me? This angle can be found in the second quadrant, third quadrant, and fourth.
It's the acronym. The acronym was CAST. If you guys can remember, the acronym is CAST, meaning in your first quadrant, all your trig functions are positive.
Yes.
And then in the second quadrant, sign is positive, and then the rest is negative. In the third quadrant, tan is positive, the rest is negative, and then in your fourth quadrant, cos is positive, and the rest is negative. Is that what you're looking for, sir?
No.
Yo.
Ah,
No. No.
Ah.
Okay. All right. Let me rephrase my question. You and I know that in the first quadrant, we have got 45 degrees. Okay?
Okay.
All right. Someone mentioned another interesting point. It's just a pity here we don't have, we are just not having this part, the mirror image of these two functions on the left-hand side. But nevertheless, you and I need to agree on this. We agree that in the first quadrant is all, in the second quadrant is T, in the third quadrant is, this is ASTC. All students take coffee. Remember that.
Indeed.
In the first quadrant, we have got all of them being positive. Okay? Or meaning all trig functions. Okay, please draw the Cartesian plane with 4 quadrants from where you are. All of you.
Done, Sam.
Done. Okay. Do you still remember that in the first quadrant, all the trig functions are positive?
Yes. Thank you. Yes,
And
sir.
then
Yes.
in the first quadrant, we just wrote capital A.
Yes,
Capital
Sam.
A meaning that all trig functions in the first quadrant are positive.
Yes. Sir.
Then, now let's go to the second quadrant. In the second quadrant, please write capital S. You done? Now, that S is saying sine and its reciprocal. Level, what is the reciprocal of sine?
1 over sine.
Cosecant,
I know.
Sam.
Cosecant. That's
Cosine,
what
yeah.
I'm looking.
Cosecant.
What?
Can cosine, cosecant. No, no, no.
Hi, Leo.
Yeah. In the second quadrant, sine and cosecant are positive. Now let's go to the third quadrant. In the third quadrant, we write capital T. Capital T means that tangent and cotangent are positive. All those other trig functions are negative. Now, in the fourth quadrant, please write capital C. Capital C, we are saying cosine and its reciprocal, which is what, Gogezo? What is the reciprocal of cosine?
Gogezo left.
Abdul? Oh, thank you, boss. Vuyo, what is the reciprocal of cosine?
Secant.
Secant, thank you. Thank you. Lebo,
Okay.
are you talking?
No, sir. Second. Okay, you're not right.
Lebo. Lebo. You know, I'm trying as hard as I can to make sure that when we leave the workshop, everybody understands what we were talking about. So your comments are worrying me. Are you okay, Lebo, on these things?
Yeah, I'm fine, sir. It's okay. I'm fine, sir. It's okay.
Okay. Now, what is this weight? I think, do you remember the word cotangent angles?
The first time
Is it-
hearing it.
I've never heard
Is
that
it-
in my life.
Is it
The first time I
co-tangent?
heard the word.
Is it what?
Sir, are you sure you're not talking about PhD things now?
Yeah, sir, the masters,
sir.
doctorates.
Yes.
Sir, we are beginners here. You can't come with
Because you're
doctorates.
going too
You know
far,
what you're
so
doing now? You're pulling a Dr. Ali on us now. Were you talking about high grade things?
Okay. Okay. Let me now take this thing off my mind. Then, well, I needed to give you the background so that when we get there, you don't struggle. You will already be familiar with it. But when we get there, then I'll remind you again. Okay. Thank you. Now, let's look at this example 2.4.1. Differentiating a function containing sine x.
so we can see the answer.
Okay, don't worry. So, to be honest with you, in particularly in grade 12, this is the section that I liked. This one, as well as that we dealt with trig, Euclidean geometry, and analytical geometry. These are the sections that I enjoyed the most.
Yes, because they are the fun ones. They are the fun ones.
I enjoyed these.
We can tell.
Most definitely.
Wow, your enthusiasm, sir. We can feel it. I know.
Really?
Yo.
Now, please, I'm begging all of you, please walk this path with me. In this case, they are saying, find the derivative of f of x, which is equals to 5x cubed times sine x. Do we all see this, no?
Yes, sir.
Yes.
Yes, sir.
Now, remember what we have been doing. Sbusiso already said we can see the answer. Don't worry about seeing the answer. This is how this thing is done. From what we have been doing, we first do what? We first get the derivative of 5x cubed. Then we multiply by sine x. Then we add the derivative of sine of x. Then we multiply by 5x cubed. Is this not what we have been doing all along?
Yes, it is.
It is with some small modifications.
Yes, with some minor modifications. Have you noticed these car manufacturers? You see cars?
What's
eh?
that? Oh,
Which
yes.
brand do you like?
I can't
Which
afford
brand
one.
do you- No. Which brand do you like? Which brand do you like?
I'll go with BMW.
Porsche, sir.
Yo,
Jesus.
I go with Porsche, sir.
Porsche.
Okay, you'll go with Porsche. Someone is going with Porsche. Someone is going with BMW.
Yes.
Let me give you an example. Let's say, look at 2019 model for either Porsche or BMW, and look at the following year's model, the very same Porsche or BMW. There will be minor modifications, and then they will say, this one is the 2019 model, this one is the 2020 model. Do we agree?
With the 20.
Are we agreeing on that one?
Yes, I agree with you.
Yes, sir.
Even now, if you can go to any dealership and say, okay, they will tell you that, oh, yes, we are now in 2023. They will say, this one, the reason it's cheap is because it's a 2022 model. And this one is a 2023 model. That's why it's expensive. And then when you look, there will be minor modifications, not major, minor. So that's why I'm saying to you, even here, That's why I'm saying I agree with Busiso to say minor modifications. What are those minor modifications? Now there is sign. Remember, we just talked about this sign and this cos. Now, in here, the interesting part is that we need to find the derivative of sine and the derivative of cos. What is the derivative of sine? We just talked about it.
Cos.
Cos X.
Negative cos. So cos.
X.
Cos.
Uncle Lebzo,
The derivative of sine,
Cos
It's
X.
cos.
Cos.
cos x. Thank you. So the derivative of sine. Okay, where is this? They are starting. Okay, let's first look at this part. Yes, this one. Now in here, the first thing is to find the derivative of 5x cubed. The derivative of 5x cubed is 15x squared times sine x. We agree. Now, when we come to this part, we are finding the derivative of sine x, which is cos x. We multiply by 5x squared. That is why then we end up having this 5x squared times cos x. Is it clear to everybody?
Yes, sir.
yes, yes.
Yes, sir.
Now, which rule was applied here?
Product rule.
Level? Is it level? Someone said product rule. Who's that?
It is
Maths.
level, sir.
Oh, is it level? Okay, thank you. Now, didn't we talk about the product rule before, you and I? Didn't we? I'm talking to everybody now.
We did,
We
sir.
did spoke about it.
We
sir.
did,
We
sir.
spoke. We spoke.
We've
Okay.
spoken about it extensively, sir.
Okay, thank you. What else did we talk about?
We spoke about the new derivatives of the cos and the sine.
What else before today? Another rule. I'm interested. We did.
Quotient rule, sir.
Quotient rule.
And the
Erika,
chain
again,
rule, sir.
Spusiso, please park your car there. Please park that Porsche there. It is overtaking Erika.
Okay, sir.
Erika,
Okay, sir.
that Porsche is very fast. Erika, please.
The
Erika.
quotient rule, sir.
Okay, thank you, Erika. Erika, now do you see example 2.4.1?
Yes.
I'm asking all of you to apply the quotient rule to find the derivative of sine of x over x.
Oh, we should do it like now. Oh, okay.
We are working on example 2.4.1 and we're using the quotient rule to find the derivative of sine of x over x.
Okay, sir. Thank you.
I got x cos of x, x times
X.
cos of
X times cos of x
minus sine x
minus sine x
as all
That's it.
all divided by x squared.
All divided by x squared.
Yes.
Let me repeat what you said. You said x cos x minus sine x all over x squared.
Yes.
Okay. Now that you ate and then you have got the energy, let me request you to talk to us about your answer.
Hello, colleagues. Hope we agree.
We don't agree.
Someone said we don't agree. Someone said, hmm?
I said, hmm? I said, hmm?
Yeah, I'm enjoying this workshop.
I would just like to say, Tando Nkosi, I agree with you, ma'am.
Level, you
Yeah,
said,
Lebu, please show yourself.
Theo.
Lebu, please show yourself and explain yourself.
No,
Level,
I mean, I agree. You know how Tando asked this question. Like she wants us to agree with her. Like it's a must.
Wow.
huh?
I hope
What?
you agree.
Wow.
I hope you agree with me. No, like she's us, yo.
She's what?
She's forcing us to agree with her.
Okay, so you disagree. Okay, now,
Agree.
Dando, they disagree with you. How did you get this answer? Dando, please share with us.
Hello, sir. Theo can explain better. Let me take over.
Hi, Bo. Hi, Bo.
I said today I'm so tired. Really? Oh, I'm just forcing myself.
Hi, Bo.
Okay. Level, do you agree?
I agree, sir.
Okay, please take us through.
Oh, okay. Yeah, like it's a function over function. So now what we need to do there, you have to first differentiate the denominator, not denominator, numerator, which is sin x. So we're gonna get cos x, and we multiply it with our denominator, which is x. We minus, okay, we take a minus sign, and
Hello,
then
sir. But Ilebo said she disagrees. I say Theo because she said she agrees with me. So I'm confused now when she's explaining. Because
Lebu said she agrees in the end.
Or she said she agrees also.
Yes.
This is
Because
South
I chose
Africa.
Theo.
Lebu's allowed to change her mind.
Tando.
Hello.
Yeah, next time you don't have to force us like to agree with you, because the
No, it's
question.
English. When you're talking in English, it's as if maybe you are forcing people. It was just a question, a simple one.
Come on, your parts, guys, please.
I wasn't like forcing you.
Emily. Come on, your
Lebu, just take us through.
Come on, your
Lebu, take us through.
Come on, your parts.
Theo, yeah, my man. This
Yes,
guy.
ma'am. Yes, ma'am.
This girl wants to kill me. Please go through. Hey, I don't wanna die.
Okay, I know, it's fine. I'll do it. So as we all know, this is the quotient rule, and pertinently, what Lebu says is we can apply the quotient rule because we have a function over a function. And this is important because I got it wrong the last time. But yes, basically the quotient rule states that, I mean, again, like the last time, I use f and g, and f is usually what's in your numerator and g would be your denominator. So the formula is basically f prime g minus g prime f over g squared. So derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. And that basically gives us as a numerator cosine x times x minus 1 times sine x. And then as a denominator, we end up having x squared. And basically, there's nothing to simplify because the end result is basically a x cosine x or cosine x squared minus sine x over x squared.
Thank you very much.
Yes.
Is there any disagreement from what Theo just shared with us? Silence means consent. Thank you.
It means yes,
now,
sir.
Remember this. Remember this from limits. You forgot. Ew, yeah.
Oh no, we remember this.
We definitely remember, Sam.
Okay, okay. You know, the most important thing that you can do to yourself ne, is to can be able to keep track. You know, how should I say it? You know, there was a time while I was in matric, ne? I could tell, even in my sleep, I could tell that this question is coming from this section, this page number. Even if it was not the exact question, but I could relate to say, okay, this question is similar to that one in that chapter, in that section. If you can be able to do that, believe me, you will go places.
We can't say do that. We can't. That's a photographic memory, Sam. And we don't
It's called a what?
have a photographic memory, Sam. We can remember in our own ways, but we can't remember the pages and sections every time saying specific questions. I can only remember that I've done this type of question before. Where, how, which section, I don't know. As long as I know that I've done this and it's done like this, then that's enough. So, yes.
Okay, you and I are saying the very same thing, but differently. As long as you can be able to remember that, okay, I saw something like this in a particular section, then I can be able to use that technique in that section to solve this. Let's get rid of the page numbers. Let's delete the page numbers from there. So you and I are agreeing on the same thing, Nesbusis.
Yes, sir.
Because the reason I'm saying that is that this, if you are able to remember where we use this, then you are aware that, okay, this is not applicable. Sorry, you are aware that this is not applicable here. So what is applicable here is this, the quotient rule. That is all that I needed to share. Now let's look at this one. Please find the derivative of f of x, which is equals to sine x times cos of x. How many minutes, Matladze, for this one?
2 minutes, sir.
Thank you. Starting from now.
Susiso is the answer.
Thank you, Susiso.
Level is done.
Hello, sir, using the quotient rule also.
Thank you, Matladze.
Oh.
Tando?
We are
Tando,
using the, hello, sir.
are you still eating?
No, I'm done. I'm saying, are we still using the quotient rule?
We are now working out exercise 2.4.1, not example, exercise. Do you see
Yes.
it?
Yeah, this one, sine x, cos x.
Yes. I thought maybe you were still eating. I was saying, yeah, that food is delicious. Yo. Makes you even lose track of what we are doing.
I'm done, sir.
Are you sure? Okay, please tell us what you got. Share with us what you got. It's because you have got the energy. We are hungry. You have got the energy. So lead us.
I got the same answer as Abdul.
Abdul hasn't yet shared his answer.
Yo.
That's the nice food. Tando, please dish for me. Your food is delicious, chef.
Yo.
Tando, nobody has shared their answers here. You are the first one. You are leading us. Please share
But
with
I
us.
know it's the same as Abdul one. Abdul, what is your answer?
Yeah.
Okay. Abdul, what did you get, my brother?
I got cos squared x minus sin squared x. Is that what you got, Tando?
I know. I got cos 2x.
Yeah, same
I
thing.
got cos squared x minus sin squared x.
Yes, it's the equivalent of cos 2x.
Okay. This one, I have to redo it. I got cos 2x.
No, that is the answer, Tando, as well. So that is the correct answer as well.
Oh.
Yes.
This topic, this module, I don't lie. I enjoy 1503.
Because I need
Yay!
cos. Eh?
Yay!
You enjoy what?
Yay! What?
1503.
They won.
You can't enjoy 1503. Uthini na? Hey, one.
You are enjoying 1503. You are a master.
Yeah, no, you're beyond all of us.
Yo.
Believe
I
me.
level this one. I have to work hard on this.
But yes, to answer your question, so cos squared x minus sin squared x is basically the equivalent of the cos double angle formula.
These modules that I'm offering, believe me, you can get a distinction.
Sir, hey, the other one, man. Hey.
So these identities and stuff.
Yes. Yes. Believe me.
Yeah, calculus, it's very plausible. Yes.
Do we agree with Abdul's answer of cos squared x minus sin squared x?
Yes, sir, we do.
Yes,
I do.
we do.
Any disagreement? Someone is saying no. Have I heard clearly?
No, sir.
Vuyo, are you saying no, or are you saying you agree with Abdul's answer?
My answer is that I agree with Abdul.
All right. Thank you.
Sir,
Yes.
It's fine again if I can say the derivative is minus sin x cos x.
Minus sin x cos x.
Yes, sir.
Is that your final answer?
That's my final answer because Abdul says his answer is cos x minus sin x.
Abdul says the answer is cos squared x minus sin squared x. That's what he said. And
Where
then
am I?
you say to me, the answer is minus sin x cos x. That's what you said, ne?
All right. I see.
No. That's what you said, eh?
Yes, sir. That's what I've said.
Okay. Level, what are you saying?
My answer is cos squared x minus sin squared x.
Sibusiso?
It's cos 2x.
Cos 2x.
Yes.
Madladze?
Cos squared x. Okay, sir.
Madladze.
My answer is cos squared x minus sin squared x.
Did I talk to Erika?
No, you haven't. And you haven't spoken to me either. And reward.
I mean, Erika. Erika, now I'm going to swap the words now. When I mean Erika, then I'll mean Theo, based on what Theo has just said. Erika.
Hello, and yeah, my answer is also cos x squared minus sin x squared.
What, Erika? Please take your time. Okay, I'm listening now. I heard something. I need to make sure that
Okay.
I hear you clearly.
My answer is cos squared x, take away sine squared x.
Okay, hang on, Erica. Let's
Take away.
clarify something. Let's clarify something, you and I, because it shows that you and I are in this marriage for a long time until death do us part. And now, this takeaway is confusing me. So if I can get clearly what you mean by this takeaway, then I'm telling you that this marriage will take us to till death do us part. Erica? Erica?
I'm here. Sorry, I've got a little distraction with me.
Oh.
So, sorry, don't be distracted. I'm getting confused by this takeaway. What do you mean by takeaway? Another way.
Negative
Oh,
sine
negative.
squared x.
Oh,
Take away is a fast food joint, say. When you take away something from McDonald's or something, the same way.
Takeaway is
Oh.
also divorce, to remove.
Okay. Thank you, Erica. You see now, you and I, we are going far.
Thank you,
Thank you,
sir.
Erica. Thank you,
Thank
Erica.
you again, sir.
Okay, Theo.
Yes,
Theo,
sir.
I think I've spoken to you, ne?
No, you haven't.
Okay,
Finally.
the stage is yours.
Thank you so much. Ladies and gentlemen, because we are part of the land of the free, the answer can be both cos squared x minus sine squared x, or if you so desire, cos 2x. Either one works.
Okay, thank you. Vuyo, you say you have got minus sine x
No,
cos.
sir. You see, the thing is that I just did this thing on my head. I underestimated this, and I did it in my head. I got the answer as negative sine x squared cos squared x.
Please repeat.
Negative sine squared x cos squared x.
Negative sine squared x times cos squared x.
Yes, sir.
That's what you have, no?
Thank you, sir.
Negative sine squared x times cos squared x. Theo?
Yes, sir.
Sorry. No. I mean, Vuyo. Vuyo, I'm worried. You see, the statement that you mentioned is worrying me and then it's causing problems. It's
Yes, sir.
causing problems based on the answer that you just shared with us. Because this is what we are looking for. We are not looking for minus sine squared x times cos squared x. We are looking for cos squared x minus sine squared x. Or alternatively, minus sine squared x plus cos squared x. That is what we are looking for.
Okay, sir. Thank you, sir.
Mahlatsi.
Yes, sir.
Mahlatsi.
Yes, sir.
Thank you, my sister. Please talk to Vuyo. What advice can you give to Vuyo before we continue?
No, I don't know, sir. He's confusing himself because he seems to understand and then having some doubts. I don't know what's wrong with him.
Please talk to him.
No, we just need to relax because here we're dealing with the product and the quotient rule. when we're having the, what's this?
All right. Yes, ma'am.
When we're having the multiplication sign, we using product, right? And when we're
Yes,
having
ma'am.
divide, yeah, when we have division, we use quotient. You take what you are given, you just substitute to our equation, and then you get your answer. That's how we do it. Are we together?
Yes, ma'am.
Okay, thank you.
Thank you, Matlazi. Matlazi, please talk to your brother. Please talk to your brother. Ask him whether indeed he understands this for the last time. How we got this cos squared x minus sine squared x for the last time.
Voyo,
Yes, ma'am.
are you following?
I do follow a little bit. With the product rule, I'm struggling a bit.
Can we help?
The product rule.
Please
Sorry,
help him. Please help him, Matlazi.
The product is the answer that you got from the multiplication sign, actually. When we talk about the product, we talk about the multiplication sign. If you are given two functions, like you're given f at x and sine x cos x, you can treat your equation as f at x, which equals to, you take that sine x, you can say it's h at x, and then take that cos x, make it g at x. Ne?
All right.
Yes, meaning between them there is multiplication sign. They can't put they can't put the multiplication sign, obviously. And then that's where you're gonna use that product rule equation. And then if you're given two equations with the division sign, it's a quotient. Quotients means divide.
Yes, I understand that.
And where are you missing then?
Now I do follow. My problem was this product rule thing.
Voyo, are you sure?
I'm very sure.
Vuyo, if you say so, not meaning to put you on the spotlight or anything, can you give us the formula of how you go about finding your product rule?
For this question, please.
For this question, it will be the derivative of sine x plus the derivative of cos x.
Okay. Okay. Can I comment?
Is that it?
Can I?
Yes.
Okay.
Okay, come in, Theo.
Sure. Voyo.
Yes, sir.
Can I have your attention for like just 3 minutes?
Yes, sir.
So product rule, basically, like the nice lady had explained, is, I'm going to try just reiterate what she said. With product rule, how you always recognize it is you usually have two functions multiplying each other, right? So
yeah,
it's going to be one multiplied by the other. So, and we'll keep it very simple to begin with. So imagine if we had 2x multiplied by x cubed. So the one function is 2x, right?
Yes.
And the other function is x cubed, right?
Damn it.
Yes. So stay with me. Let's continue.
You.
Yes, I know. So remember I said the one function is 2x and the one function is x cubed, right? So what the product rule says is to find the derivative when you've got a situation where you've got two things being multiplied by each other. You have an algorithm, like Sir likes to say. And the algorithm basically says It's basically the derivative of the first function multiplied by the second function, unchanged, plus the first function multiplied by the derivative of the second function. So in the essence, what you do here is at every single point in time, if you take the derivative of the one, you keep the other constant. Plus, now that you've taken the derivative of the other one, you will now take the derivative of its derivative and you keep the other one constant. So basically, at every point in time, when you pair them, you'll have one that's being derived and one that's being kept the same. But if you derived A initially and you kept B the same, in the second part of the equation after your plus, you will now derive A and keep B the same. So if you've derived A and kept B the same, second time around, you're going to derive B and keep A the same. Do you see it? So in the end, what's going to happen is when you think about it systematically, you will always have one that was kept the same and one multiplied by one that was derived. So in the case of this one, to put this into practice, I'm going to our two functions here are sine x multiplied by cosine x, right? Hello?
Vuyo?
Voyo?
Is Vuyo still with us?
Fell asleep.
Yeah, yeah,
But
okay.
is he with us?
Oh, guys.
Maybe he's sleepy.
No, before he sleeps, we say
in there,
I think he's having network problems. He went out. So.
Say he's gone. He's gone. He's gone.
He's gone.
Oh. Yeah, he's not in the meeting, so I'm not sure if it's network or what's going on. I think he might be having network issues.
Oh.
Or maybe load shedding.
Load shedding.
Just as I was getting in my stride.
Hey man, and yeah, man, I'm listening, man. You're about, Kantivuyo is not here, man. And that's what
he has stood me up like a bad first date.
I guess he was helping you warm up, Theo.
Oh, guys. Oh.
Okay. Thank you for
making Vuyo sleep. Sure.
No. Thank you. Thank you all for helping out each other. Let's keep up with this spirit.
He's back.
That's okay. Yes, he's back. Theo. Come on, Theo. Theo, it's yours. Continue.
Okay, I'll keep quiet.
Mr. Boyo.
Hey, yes, sir, I'm back. My phone just went flat. I'm back.
No, it's fine. It's fine, sir. Welcome back, first and foremost. Secondly, what's the last thing you heard me say?
I heard you saying if we had two functions multiplying each other,
yes,
a function of 2x multiplied by a function of 3 cubed.
Yeah, 3 cubed or 3x, whatever. Yes, yeah.
Yes, sir. That's all I heard.
Okay, so I know where we are. So in the essence, you understand the concept of us having two functions multiplied by each other, where we said it's the 2x. Let's actually keep it simple. Let's say 2x multiplied by x squared. Is that fine?
Yes, sir.
Cool. So what the product rule is now going to entail is at any point in time, to get the derivative of the whole thing, you will derive the first part and keep the second part the same. Plus, keep the first part the same and multiply it by the derivative of the second part. So to put this into practice, because again, remember we're working with our 2x and x squared, right? So yes, to get the derivative of that sum, we would derive 2x, which would give us 2, right?
Yes, sir.
And we'd multiply 2 with x squared. You see, we've kept the second part the same.
Yes, sir. Yes, sir. By x squared.
Yes, so it's going to be our 2 times x squared and then plus, right?
Yes, sir.
And now we are keeping our 2x the same. So it's going to be plus 2x times the derivative of x squared, which is
2x.
There we go. And that's it. Literally, you're done.
All right. Yeah. Thank you.
So now let's wait. We are not done. Let's try this example together. the one we had
Yes,
to do, which is we must find the derivative of sine x multiplied by cos x, right?
Yes, sir.
So we're going to derive the first part, keep the second part the same, plus the first part multiplied by the derivative of the second part. So let's do it. For the first part, what would be the derivative of sine?
It will be cos
Cool. So
X.
it's going to be cosine x multiplied
by sin x.
Think about it carefully. Think about it
I
carefully.
mean, okay, by cos x.
Okay. Let's take it back again. So first part, we're going to derive sine, which is going to be
It will be minus.
No. I said, let's go back. I wanted to get it right first time around and do the whole thing.
All right.
Yeah.
Okay.
So let's derive the first part. Derivative of the first part, which is sine, is going to give us.
It will be cos x.
And then we're going to multiply cos x with
cos x.
Perfect. And then we're going to have our plus, right?
Yes, sir.
And then after that, we're going to keep sine the same and multiply it with
the derivative of cos x.
And what's the derivative of cos x?
It's minus sin x.
Perfect. So what do we now have?
Now we have cos squared x.
Yes.
Minus sin squared x.
Slow clap.
Ow. Welcome to the team, Vuyo.
Slow clap.
Thank you.
Vuyo,
Yes, sir.
please thank Theo for the explanation shared with you.
Yes, sir. Thank you, Theo, for the explanation.
Always, man. Anytime.
Thank you.
Oh yeah,
Thank you,
sir.
Vuyo.
Then
Thank
Mahlati
you.
must get her flowers also. Can you keep Mahlati her flowers?
Yes, Mahlati
also?
must get the flowers first and she must get them last too. All of these are for her.
Yes.
Thank you.
Got your flowers, Mahlati.
Yes, I was
Thank
literally just a
you.
translator. That's it.
Yeah, so before I'm leaving now. I'm
Where are you
going to-
going now? You can be saying you're leaving now. Where are you going?
We are happy.
Yes, sir, I'm having a class now, 7 o'clock.
Oh, okay.
Oh.
Okay.
Yes, sir.
Say what you want to say. Yeah.
I'm going to send a question paper, previous question paper for 2023, January, to Ma'am Dikeleti. So she will send it to members, family.
Thank you very much.
Thank you, Lebzo. Thank you, Lebzo. Rush to the next meeting. We're now strong.
I'm going to send you a previous question paper 2023.
Okay. All right.
Yes, sir.
All right, my dear. Thanks. We'll do.
Mama Nagamana, go to the next meeting. Bye.
Okay. Thank you, Levo. Go with the child to the next meeting. Okay. All right. Let's continue taking into account that joined a few minutes earlier. Let's try to make up for those few minutes. Now, finding the derivative of a function containing what? Cos x. Remember what we talked about at the beginning of the workshop, ne? You forgot?
Ish.
So we talked about many things. So.
Except the homework.
Except the homework. We talked about the derivative of sine and cos.
Yes, we did.
Yes.
And we also talked about the cost diagram.
Yes. Now, I like that word that Busiso mentioned. Busiso, you said what? Modified. We are continuing to modify.
Yes.
Yes, let's continue.
Further and further.
Yes. Until the end. Yesterday you talked about the bacteria. We'll get to those bacteria that you are looking for. Don't worry.
Exponential growth and decay.
We are getting there.
Mm.
Do you see this example 2.4.2?
Mm.
Please find the derivative of g of x.
So this one,
which is equals to cos of x, which is equals to cos of x all over 4x squared. Theo, how many minutes for this?
So let's do 4. And the reason why I would have initially said 3, but I wanted to do 4 so that Mr. Voyo can do it with us and double check.
Thank you, brother.
So the last minute is for all of us to double check, and then if it's okay, I would like it if Mr. Voyo and I could try lead the class with it to see if we understand. Because I remember the last time we also did quotient rule together.
No problem,
Let's
brother.
just let him start.
No
let him
problem.
give the answer first.
Yes. Thank you, family.
So this is done, by the way.
Of course. Hey.
I'm driving a Porsche, man.
Yeah, you're driving a Porsche. Okay. All right, I've noted that. Okay, those who are finished, Spuso is finished, Matlat is finished, Erika is finished, Abdul is finished. Theo goes hand in hand with Voyo, and then Voyo will lead us. Except Voyo and Theo, have I missed out anyone?
Yes, I think I'm done, yeah.
Are
you sure, my brother?
Yes, sir.
Okay. Please talk to Theo.
Yes, sir. Theo.
Oh, Mr. Voyo, are you good?
Yes, I get my answer as negative sin x times 4x squared minus 8x cos x over 4x squared to the power of 2.
Mr. Voyo, can I say something?
Yes, sir.
You are brilliant.
Yeah.
You are brilliant.
You can finish the class. We are done.
No,
the job is done.
Yeah,
it's done. It's finished.
Thank you. Thank you, sir.
Brilliant.
Yes, sir. Thank you for the help.
No, thank you, sir. Yay.
Please clap hands for yourself, Voyo.
Mr.
Thank you, brother.
Legend.
It's all in the name of learning together.
Thank you, sir.
Yes. We are here for each other.
Of course, sir.
Yes. Now let's go and look at the last activity for the day. So, is this what you found? Voyo, is this what you found?
Yes, sir.
Okay. Or no, either this or this. Okay. Now, please, and Voyo will lead us on this one. Please, find the derivative of x over cos of x. Thank you, Abdul. Abdul, now it is going to be, can I pair you with Voyo, but Voyo leading us in terms of giving us the answer?
The what is done?
Okay.
Sir,
Abdul?
No problem, sir.
Okay, thank you. Okay, Matlat said is finished. People were talking, then I captured. Abdul is also finished. Who else is finished?
I'm done, sir.
Erika is finished.
The what is done?
Theo, Erika, Sbusiso. I captured Matlat, I captured Abdul, Theo, Erika, and Sbusiso. Who else?
Reward.
Reward, where have you been hiding, my brother?
I've been here all along, sir.
Really?
Yes, sir.
What time did you join?
It's been a while, sir. I've been here and sir.
Yo, I'm sorry.
Yes, it's Vuyo. I'm done.
Okay. Vuyo,
Yes, sir.
now Abdul.
Yes, Mynheer.
Abdul, here is
Yes.
my request. I'm requesting you to talk to Vuyo and Reward at the same time. My apology. I was not aware that Reward was here with us. Because at the beginning, when I took down the names, Reward was not here. That's why I missed him.
Okay, no problem, sir. Mr. Reward, can I quickly bring you in since you are still fresh on the platform? Did you manage to work out the derivative?
Yes, I did.
Pardon?
Yes, I did. I did work it out.
Okay, what did you get for your derivative?
Okay, I'm getting. Oh, sorry. I think I did a mistake here. Quickly, I got cos x, and that's cos x plus sine x times x over x. Oh, shucks. Yeah, over cos squared x. Sorry. So
Okay.
that's
Vuyo,
cos
do you
x.
agree?
Please repeat, brother.
Yes, so that's cos x plus. Can everyone hear me?
Yes, sure, go
Yes,
ahead.
we can hear you.
So that's cos x plus sine x over cos x squared or cos squared x.
Okay, Vuyo, do you agree with Mr. Reward in terms of what he got?
Yes, I do agree. It's cos x plus x sine x all over cos squared x.
I agree with you, Mr. Vuyo. However, I feel like with Mr. Reward's answer, something was missing. It's not the same as yours if I heard him properly.
Yeah, I forgot to put the x there.
Okay, so you agree that the X was supposed to be there.
Yes.
All right. Family, I'm also going with Mr. Vuyo's answer of cos x plus x sine x over cos squared x. Do we agree?
I concur.
Erica, do you also agree with us?
Erika Matadzi and Matadzi. And Sbusiso as well.
Sbusiso agrees.
Okay. Erika and Matadzi.
Okay.
Hello. Someone is saying hi. Hello.
Hello.
Who
What's the
told you?
answer, sir? No, I didn't hear your answer. Can you please repeat?
Okay, the answer so far the colleagues are agreeing on is cos x plus x sine x all over cos squared x.
Yeah, I agree.
Okay, we are left with Miss Erica's vote now.
Tando agrees also.
How? Number one. Miss
You see
Erica,
now,
please cast your vote.
Now I was forgetting Tando. Tando, it's because
Tando's
people
enjoying the food. Say.
Please, people.
No, say
let's-
I just
let's
finished
all
it now.
talk.
I was
Let's
still
all
working it
talk.
out.
No, please, let's all talk so that I'm not on that page where I can be able to see your names. Let's all talk. Let's all participate, please. Abdul, you said we are waiting for the vote from Eric. Erica.
Yes, we're waiting for Miss Erica to cast her vote. But so far, the majority are agreeing. So I believe that we will go with the answer. I'm not sure if she will come in onto the platform and confirm with us, or she probably got something different.
Erica? Is Erica still with us?
Yes, she looks to be here, sir.
Maybe she's also enjoying the food.
Yeah, hey, Tando, you see you and your food, you.
I Abdul.
Okay, if there is a consensus on the answer that Vuyo and Reward, that Vuyo Reward had to make an adjustment, had to rework the answer to what Vuyo shared with us, then I think then we can call this a night. This is the answer that we were looking for. Thank you, Vuyo.
Agree.
Thank you, sir.
Thank you,
everybody.
much. Do we agree that, okay, let me not say, do we agree? Let me not enforce you.
Force people.
Yes. Are we okay? Are we all okay to say we can call it a night?
We agree,
No,
sir. I
sir.
believe I'm okay. I'm okay.
I don't agree.
You don't agree? Okay, please talk to us. What can we do?
Not without at least a homework.
Sugar Matota. I like the confidence. Vuyo.
Confidence,
Yeah,
bro.
us homework.
Confidence.
Yeah, because Vuyo wants it.
He's here.
We want the homework.
I know.
Okay.
So please do the right thing.
Okay.
Give us some responsibility.
Let me go and look for a homework. Nah, don't worry. Don't worry. Don't worry. Don't worry. Hang in there. 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 I'm with you. I know where I'm going to find it. I know where it will be. Please. Do you see exercises 2.4E.1?
Yes, sir.
Please find the derivative of y with respect to x. dy dx, that means that you are differentiating y with respect to x.
Yes, sir.
Are we doing for number 1 and 2?
I think.
Yes, please.
Am I being fair? Am I being fair here? Hang on. Hang on. Hang on. Hang on. Hang on before you do this. Hang on. I want to check something. I want to check. No, I don't want to show you the answers. Okay. All right. I think I'll be fair. I'll be fair to you if I can ask you to do number 4 and number 7.
All right.
4 and 7, because I'm of the view that we have already talked about those trig functions in there. Let me write
4
it
and
down.
7.
4 and 7.
Okay, 4 and 7, Sam.
Yes.
Okay, Sam. I'm already done with 1 and 2, sir, so.
I understand, but I think somehow.
I understand, sir. I understand, Sam. 4 and 7.
Okay.
Sam.
Hey, so I'm worried that when Lerato comes back, he's not going to have a job anymore.
Exactly.
I am very
So
worried.
don't take Lerato's job.
You've lived.
Unlike Lerato, I'm fast and precise. Yeah.
We don't want to start fighting. We'll start witchcrafting each other here in terms of who's fast and whatnot. So if Lerato comes back, please give him his job.
Don't worry, I'll slow down.
Yeah, when he comes back, you must just literally fade into the abyss because yay.
Yeah, I'll be a ghost. Don't worry.
Thank you very much. But until he's back, yes, just keep doing, man.
Okay. Can we? Oh, have you all captured number 4 and number 7?
Yes. So.
Okay. Thank you. So tomorrow we'll start by verifying the answers for number 4 and number 7, and then we'll continue from where we stop.